students, this is Sivakumar, 12th Standard Business Mathematics and Statistics, chapter number 2, exercise 2.10. We are going to study about improper definite integral. If n is a positive integer, then integral 0 to infinity is called the improper definite integral. X power n e power minus ax dx, that is equal to factorial n divided by a power n plus 1, or factorial n can be represented in this way also, n factorial, same only, divided by a power n plus 1. Some properties are there. First property, gamma of n. What it is? Gamma of n. It is also gamma integral. I note down here, gamma integral. This formula is specially for the limits 0 to infinity, remember. Now, property number 1, gamma of n, that is equal to n minus 1 into gamma of n minus 1 if n is greater than 1. Second one, gamma of n plus 1, that is equal to n into gamma of n if n is greater than 0. Third one, gamma of n plus 1, that is equal to factorial n. It's a very important one. This property can be applicable if n is a positive integer. And the fourth one, gamma of half 1 by 2, that is equal to root pi. Now we can do first problem, first subdivision, evaluate gamma of 4. Okay, that is equal to 4 is a positive integer. So we can apply the fourth property. For applying the fourth property, look at the left hand side of the property, gamma of n plus 1. So we have to write 4 in that form of n plus 1. How to write? Shall we write 4 as gamma of 3 plus 1? 4 and 3 plus 1 are same. Look at that. I write the property gamma of n plus 1, that is equal to factorial n if n is a positive integer. Here n, that is equal to 4. Actually we applied third property, not the fourth one, third property, remember. Okay, now what is the right hand side of the property? Factorial n. Compare these two. What is the value of n, please? I have written here n, that is equal to 3, not 4. So answer 3 factorial. 3 factorial can be written as 3 into 2 into 1, that is equal to 6. Factorial n is a continuous product of n natural numbers. Factorial n means n into n minus 1 into n minus 2 going on up to 1. So factorial 3 means 3 into 2 into 1, right? 3 2s are 6, 6 1s are 6. So first subdivision, problem number 1, first subdivision is over. I'll be teaching the problem number 1, second subdivision in the next video. Okay, thank you children. This is Sivakumar, 12th Standard Business Mathematics and Statistics, chapter number 2, continuation of exercise 2.10. Problem number 1, subdivision number 2. Evaluate gamma of 9 by 2. 9 by 2 is not a positive integer. So a 9 by 2 is greater than 0. It's a positive number only. So in that case, we have to apply the property number 2. You can go for property number 2, or even you can apply property number 1, because 9 by 2, that is equal to 4.5, correct? 4.5, that is absolutely greater than 1. So can we apply 1 or 2? I am going to apply 1. Okay, I write the property here, gamma of n, that is equal to n minus 1 gamma of n minus 1, since n, that is equal to 9 by 2, which is greater than 1. Okay, here n n here 9 by 2, n that is equal to 9 by 2, substitute in the formula. 9 by 2 minus 1 gamma of 9 by 2 minus 1. What's the formula please? N minus 1 gamma of n minus 1. So n minus 1 gamma of n minus 1. You have to simplify. 9 by 2 minus 1, that is equal to, you know very well, I do here 9 by 2 minus 1 equals 9 minus 2 by 2. 2 is a LCM, that is 7 by 2. You can write over here 7 by 2 gamma of 7 by 2. So write this 7 by 2 as it is. Gamma of 7 by 2. Once again I am going to apply the same property. Now n that is equal to 7 by 2, that is also greater than 1. Okay. Now substitute in the same formula. 7 by 2 minus 1 gamma of 7 by 2 minus 1. Write 7 by 2 as it is. 7 by 2 minus 1 equals 7 by 2 minus 1 is 7 minus 2 by 2, that is equal to 5 by 2. So this can be replaced by 5 by 2 gamma of 5 by 2. So that is equal to, write 7 by 2 into 5 by 2 as it is. For gamma of 5 by 2 you have to apply the same property. Okay. Now n that is equal to 5 by 2, which is also greater than 1. Therefore formula here it is. What is the formula? N minus 1 gamma of n minus 1. What is the value of n? 5 by 2. That is equal to 7 by 2 into 5 by 2 into 5 by 2 minus 1, that is equal to 5 minus 2 by 2, that is equal to 3 by 2. So 3 by 2 gamma of 3 by 2. Close the bracket. So 7 by 2 into 5 by 2 into 3 by 2. Then once again you have to apply the formula for gamma of 3 by 2. Here n that is equal to 3 by 2, which is greater than 1. Once again the same formula, n minus 1 gamma of n minus 1. What is the value of n? 3 by 2. So 3 by 2 minus 1 gamma of 3 by 2 minus 1. Close the brackets. That is equal to 7 by 2, 5 by 2, 3 by 2. Then 3 by 2 minus 1 you have to simplify, that is 3 minus 2 by 2 equals 1 by 2. So inside the brackets you have to write half gamma of equals 7 by 2, 5 by 2, 3 by 2 into 1 by 2 into gamma of half. Here it is. What is the value? Root pi. So this can be replaced by root pi, since gamma half equals root pi. Then we have to simplify. 7 5s are 35. 35 3s are 105 into root pi divided by 2 2s are 4, 4 2s are 8, 8 2s are 16. So problem number 1, subdivision 2 is over. I'll be teaching the third subdivision in the next video. Thank you children. Students, this is Sivakumar, 12th standard business mathematics and statistics, chapter number 2, continuation of exercise 2.10. Problem number 1, third subdivision. Evaluate integral 0 to infinity e power minus mx into x power 6 dx. Look at the limits 0 to infinity and of the form x power n into e power minus ax. So we can apply the gamma integral. Integral 0 to infinity x power n into e power minus ax dx equals factorial n divided by a power n plus 1. Already I have given that. Same formula only I have written here. I am going to compare these two. X power n, x power 6. What is the value of n? 6. N can be replaced by 6. E power minus ax. e power minus mx. So a can be replaced by m. That is equal to, here's the right answer of the formula, factorial n that is equal to 6 divided by a can be replaced by m, n plus 1, n value 6 plus 1, that is equal to factorial 6, that is 6 into 5 into 4 into 3 into 2 into 1. Keep on reducing 1, start from 6 until you get 1, divided by m power 7, that is equal to 6 5s are 30 into 4 3s are 12, 12 2s are 24, 24 1s are 24, divided by m power 7, that is equal to, you have to multiply 0, 4 3s are 12, balance 1, 3 2s are 6 plus 1, 7, 720 divided by m power 7. Or you can stop at this stage, factorial 6 divided by m power 7. Both the answers are correct only. I will be doing the fourth subdivision in the next video. Thank you, children. This is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 2, continuation of exercise 2.10. Problem number 1, subdivision number 4. Evaluate integral 0 to infinity e power minus 4x into x power 4 dx. This is called improper definite integral. What it is called? Improper definite integral. For evaluating, we can apply the gamma integral. It's very similar to the previous subdivision. 0 to infinity x power n into e power minus ax dx, that is equal to factorial n divided by a power n plus 1. Now I have to compare these two, n value and a value. I have to find out. X power n, x power 4. What is the value of n? 4. E power minus ax, here e power minus 4x. So a can be replaced by 4 equals. Formula right hand side, factorial n value is 4 divided by a. What is the value of a? That is also 4. Power n plus 1, that is 4 plus 1. That's it, you have to simplify. Factorial 4, that is equal to 4 into 3 into 2 into 1 divided by 4 power 4 plus 1, that is equal to 5 equals. 4 3s are 12, 12 2s are 24, 24 1s are 24, divided by, I write 4 for 5 times because 4 power 5 means 4 has to be multiplied for 5 times. We can simplify 4 table how many times? 6 times. And we can divide by 2 table 2 times, 3 times. That's all. That is equal to 3 in the numerator. 4 4s are 16, 16 4s are 64, 64 2s are 128. Or we can write 4 factorial as it is divided by 4 power 5. 4 plus 1, that is equal to 5, 4 power 5. You can write any one of them. Both the answers are correct only. So subdivision number 4 is over. I will be teaching problem number 1, subdivision 5 in the next video. Thank you, children. This is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 2, continuation of exercise 2.10. Problem number 1, subdivision number 5. This is the last subdivision in problem number 1. Evaluate integral 0 to infinity e power minus x by 2 into x power 5 dx. 0 to infinity, write x power 5 first. E power minus x by 2 can be write e power minus half x. Same only. X into 1 x by 2. These two are same only. So definitely we have to apply the gamma integral. Integral 0 to infinity x power n e power minus ax dx equals factorial n divided by a power n plus 1. So compare these two. X power n, this is x power 5. What is the value of n? 5. So n can be replaced by 5. E power minus ax, here e power minus half x. So a, that is equal to half. Factorial n value 5 divided by a value 1 by 2. Power n plus 1, n value 5, so 5 plus 1. Have to simplify. Factorial 5, that is equal to 5 into 4 into 3 into 2 into 1. Stop at 1. Divided by half whole power 6. That is equal to 5 4s are 20. 23s are 60. 62s are 120. 120 into 1 is 120. Divided by 1 power anything is always 1 divided by 2 power 6 equals 120 divided by 1 divided by 2 power 6, that is equal to 2 power 6, 2 into 2 into 2 into 2 into 2 into 2. 2 2s are 4, 2s are 8, 2s are 16, 2s are 32, 2s are 64 divided by 64 equals 120. This division becomes multiplication. 1 by 64 reciprocal is 64 by 1. 64 by 1 means 64. You have to multiply. So 120 into 64. 4 into 0, 0. 4 2s are 8. 4 1s are 4. 6 into 0. 6 2s are 12. Balance 1. 6 1s are 6 plus 1, 7. Add 0, 8, 6, 7. 7, 6, 8, 0. Over. So problem number 1 is over. I'll be teaching problem number 2 in the next video. Thank you, children. This is Sivakumar, 12th Standard Business Mathematics and Statistics, chapter number 2, continuation of exercise 2.10. Problem number 2. This is the last problem in this exercise. You are given f of x, that is equal to x square into e power minus 2x when x is greater than or equal to 0. And f of x equals 0, otherwise, that means if you draw a number line, you can easily understand. Generally the number line range from minus infinity to plus infinity. What's the number here? You have the number 0, 0 alone. So x greater than or equal to 0 means right hand side of 0. So whether you are given greater than 0 or greater than or equal to 0, you have to consider the limits as 0 to infinity. Okay. Then therefore integral 0 to infinity, it is also given like that, 0 to infinity only, f of x dx. In 0 to infinity, f of x equals, what is f of x? X square into e power minus 2x. Otherwise means in this interval f of x equals 0. You no need to consider this interval because f of x value is 0. You have to consider this interval only. So 0 to infinity f of x dx, 0 to infinity f of x here, it is what it is, x square into e power minus 2x dx. So we can apply the gamma integral. Integral 0 to infinity x power n into e power minus ax dx equals factorial n divided by a power n plus 1. Compare these two. X power n, here x power 2. Therefore n, that is equal to 2. E power minus ax, here minus 2x. So a value please 2. Substitute in the formula. Factorial n value is 2 divided by a, that is equal to 2 power n plus 1. N value is 2, so 2 plus 1. Have to simplify. Factorial 2, that is 2 into 1 divided by 2 plus 1, that is equal to 3. 2 power 3. 2 ones are 2 divided by 2 power 3 means 2 into 2 into 2. Otherwise you can directly write 8. 2 to get cancelled. What will be the numerator? 1. So 1 divided by 2 2s are 4. So problem number 2 is also over. So exercise 2.10 is completely over. I'll be teaching exercise 2.11 in the next video. Thank you, children. Hi students, this is Sivakumar, 12th Standard Business Mathematics and Statistics, chapter number 2, Exercise 2.11. Definite integral as a limit of a sum. As a limit of a sum. Look at the formula. Integral a to b f of x dx equals limit n tends to infinity and h tends to 0. This is infinity. Sigma r equals 1 to n h into f of a plus r into h, where h equals b minus a by n. Then four results are there. First one, sigma r equals 1 to n a, where a is a constant, that is equal to a n. Second one, sigma r equals 1 to n r equals n into n plus 1 by 2. And third one, sigma means summation, sigma r equals 1 to n r square equals n into n plus 1 into 2n plus 1 whole divided by 6. And the fourth one, sigma r equals 1 to n r cube equals n into n plus 1 by 2 the whole square. These three formulas we have learnt in 10th standard. Exercise 11. Evaluate as the limit of the sum. Problem number 1. Integral 0 to 1 x plus 4 dx. This is a keyword for you, limit of the sum. Here f of x equals x plus 4. A, that is the lower limit, and b is the upper limit. This is f of x, because integral a to b f of x dx, f of x x plus 4, a that is equal to 0, b that is equal to 1. A that is equal to 0 and b that is equal to 1. First we can find h that is equal to b minus a by n, b that is equal to 1, a that is equal to 0 divided by n that is equal to 1 by n. Then you have to calculate f of a plus r into h, that is equal to f of a value 0 plus r into h value 1 by n, that is equal to f of 0 plus anything is same thing, you just write r into 1 by n, r into 1 by n that is equal to r by n. So you have to calculate f of r by n. Look at that. Here f of x that is equal to x plus 4. Instead of x, what is here? R by n. So replace x by r by n. That is r by n plus 4. We know that integral a to b f of x dx that is equal to limit n tends to infinity, h tends to 0. Here is the formula. Sigma r equals 1 to n h, sigma r equals 1 to n h into f of a plus r into h, where h equals b minus a by n. After that, write the question. A to b 0 to 1 f of x x plus 4 dx, 0 to 1 x plus 4 into dx equals, once we find h in terms of n, you no need to write h, you write n alone. Limit n tends to infinity, sigma r equals 1 to n h. What is the h? H value please 1 by n into f of a plus r into h. Here it is. What's the value? R by n plus 4. R by n plus 4 equals limit n tends to infinity, sigma r equals 1 to n 1 by n into r by n plus again sigma r equals 1 to n 1 by n into 4. Tell you again, sigma r equals 1 to n 1 by n into r by n plus sigma r equals 1 to n 1 by n into 4 equals limit n tends to infinity 1 by n into n, that is 1 by n square. So limit n tends to infinity is common for both the terms. So write n by infinity 1 by n into n, that is equal to n squared, so 1 by n squared sigma r equals 1 to n r plus write 1 by n first, sigma r equals 1 to n 4 equals limit n tends to infinity, write 1 by n square as it is, sigma r equals 1 to n or result here it is, that is equal to n into n plus 1 by 2. This can be replaced by n into n plus 1 by 2. Then 1 by n as it is, sigma r equals 1 to n 4. 4 is a constant. It should be treated as a. So result number 1. Sigma r equals 1 to n a, that is equal to an. Here what is the value of a? 4. So you write 4n. n get cancelled. Here 1n get cancelled. For your reference I write the note. This one direct formula. For this one only I write the note. Since sigma r equals 1 to n a, that is equal to an. Since okay, that is equal to limit n tends to infinity. Write the constant 1 by 2 first, 1 by 2, then n plus 1 by n. 1 by 2 into n plus 1 by n. 1 by 2 into n plus 1 by n plus. So n already cancelled. So 1 into 4, 4 equals n tends to infinity. Write 1 by 2 into n by n plus 1 by n. It can be separated as n by n plus 1 by n plus 4. Limit n tends to infinity 1 by 2 into both n get cancelled 1 plus 1 by n plus 4. After that only you have to replace n by infinity. Now 1 by 2 into 1 plus 1 by n can be replaced by infinity plus 4. That is equal to 1 by 2 into 1 plus 1 by infinity value is 0. The reciprocal of infinity, that is 1 by infinity, 1 by infinity value is 0 plus 4 equals 1 by 2, 1 plus 0 is 1 plus 4 equals half into 1 is half plus 4 equals 1 plus 2 4s are 8 divided by 2, that is equal to 9 by 2. That is the answer. Can verify. I do the verification also. How to verify the answer is correct or wrong? Very simple, but no mark will be given for this verification, just for our reference only. The question is integral 0 to 1 x plus 4 into dx. Correct? X dx integration you know very well, x power 1 plus 1 divided by 1 plus 1 plus 4 into dx, 4 integral dx is x. Directly I have written, you know that formula, Since integral x power n dx formula, please, x power n plus 1 by n plus 1. Have applied this formula. N value is 1, so 1 plus 1 divided by 1 plus 1. 4 is the constant, so only dx integration is x. Just you have to apply the limits. X power 2 by 2 plus 4x, limit 0 to 1. What is the upper limit? 1. Replace x by 1. 1 squared is 1 by 2. 4 into 1, 4. Upper limit over. Minus. Substitute x equal to 0. 0 square, 0. 0 by anything is 0. 4 into 0, 0. 0 plus 0, 0. Totally 0 only. Equals 1 plus 2 4s are 8 divided by 2, that is equal to 9 by 2. Look at that, same 9 by 2. Okay. So problem number 1 is over. I'll be teaching problem number 2 in the next video. Thank you, children. This is Sivakumar, 12th Standard Business Mathematics and Statistics. Chapter number 2, continuation of exercise 11. Now problem number 2. Evaluate the following integrals as a limit of the sum. Integral 1 to 3x dx. Here f of x equals, this is of the form integral a to b f of x dx. So which one is f of x? X. A is the lower limit 1 and b, that is upper limit 3. Then you have to find out h. H, that is equal to b minus a by n. B, that is equal to 3. A, that is equal to 1 divided by n, that is equal to 2 by n. Then you have to find out f of a plus r into h equals f of a value is 1 plus r into h value is 2 by n. That is equal to f of 1 plus 2 into r, 2r by n. We have f of x. F of x equals x. So what is x? 1 plus 2r by n. So replace ex by 1 plus 2r by n. So we will be getting 1 plus 2r by n. Then we know that integral a to b f of x dx, that is equal to limit n tends to infinity, h tends to 0. Here we have the formula sigma r equals 1 to n, sigma r equals 1 to n, h into f of a plus r into h, where h, that is equal to b minus a by n. Therefore, integral a to b f of x dx, there is a given question. Integral 1 to 3 x dx equals limit n tends to infinity, h tends to 0, sigma r equals 1 to n. I am going to replace h by, what is the value of h? 2 by n. Since no h at all, so you no need to introduce h. You have replaced h by 2 by n, you just write n tends to infinity only. Then f of a plus r into h, here it is. What is the value? 1 plus 2r by n. 1 plus 2r by n equals limit n tends to infinity, sigma r equals 1 to n. You just multiply 2 by n into 1, that is equal to 2 by n, plus 2 into 2, 4, or divided by n square. That is equal to limit n tends to infinity, can be separated as first one, sigma r equals 1 to n. Have to retain 1 by n outside the summation and 2 inside the summation. So 1 by n into 2, that is equal to 2 by n. Next, again sigma r equals 1 to n, 4r by n squared, retain 4 by n squared outside the summation, and r is inside the summation. Limit, that is equal to limit n tends to infinity 1 by n sigma r equals 1 to n 2. What form it is? Sigma r equals 1 to n a. Here a equals 2. A is a constant. I write the formula. We know that sigma r equals 1 to n a, that is equal to an. So here what is the value of a? A that is equal to 2. So therefore can write as 2n plus 4 by n square as it is. 4 by n square as it is. Sigma r equals 1 to n, or you know the formula, directly can write n into n plus 1 by 2. Already given this result. Equals limit n tends to infinity. N get cancelled, 2 ones are 2, plus 1 n get cancelled, 2 get cancelled 2 times, 2 into n plus 1 divided by n. That is equal to limit n tends to infinity 2 plus 2 into, it can be separated as n by n plus 1 by n. N by n plus 1 by n. N get cancelled. So limit n tends to infinity 2 plus 2 into 1 plus 1 by n. 2 into both get cancelled means what will be there? 1 plus 1 by n. Now replace n by infinity. So write 2 plus 2 into 1 plus 1 by n. What is the value of n here? Infinity. That is equal to 2 plus 2 into 1 plus 1 by infinity value 0. So 1 by infinity equals 0. That is equal to 2 plus 2 into 1 plus 0 is 1. 2 plus 2 ones are 2. 2 plus 2 equals 4. Problem number 2 is over. Before that, I'll be verifying. How to verify the answer is correct or wrong. The given question is integral 1 to 3 x dx. You know that integral x power n dx formula x power n plus 1 by n plus 1. What is the value of n here? 1. So it can be x power 1 plus 1 divided by 1 plus 1 according to this formula. Limit 1 to 3 equals x power 2 divided by 2, limit 1 to 3. Write 1 by 2 first. 1 by 2. So we have only x square. Apply the upper limit. 3 square minus lower limit 1 square. That is equal to 1 by 2. 3 square value 9, 1 square value 1. 1 by 2 into 9 minus 1 equals 8. 2 table cancel 4. 4 ones are 4. Look at the answer. Same answer only. This is only verification part. So problem number 2 is over. I'll be teaching problem number 3 in the next video. Thank you, children. This is Sivakumar, 12th Standard Business Mathematics and Statistics, chapter number 2, continuation of exercise 2.11. Now problem number 3. Evaluate as the limit of the sum integral 1 to 3 2x plus 3 into dx. Here f of x equals 2x plus 3. A is the lower limit 1 and b is the upper limit 3. Then you have to find h that is equal to b minus a by n. B that is equal to 3 minus a that is equal to 1 divided by n equals 2 by n. Then you have to find f of a plus or h equals f of a value 1 and h value 2 by n. A value 1 or into h value 2 by n equals f of 1 plus 2 into r 2 r by n equals, what is f of x? F of x equals 2x plus 3. So replace x by 1 plus 2 r by n. So 2x plus 3. What is x? 1 plus 2r by n equals 2 ones are 2. Then multiply these two. 2 into 2, 4r by n plus 3 equals, add together, 5 plus 4r by n. Then write the formula: integral a to b f of x dx, that is equal to limit n tends to infinity, h tends to 0, sigma or equals 1 to n h into f of a plus r into h. Therefore, question is integral 1 to 3 2x plus 3 into dx. 1 to 3 2x plus 3 into dx equals limit n tends to infinity only, no need to write h, tends to 0, sigma or equals 1 to n. H can be replaced by what is the value of h? H, that is equal to 2 by n. So since h in terms of n, you no need to write h tends to 0 in the second line. Then f of a plus r into h, here it is. What is the value? 5 plus 4r by n equals limit n tends to infinity, sigma or equals 1 to n, multiply 2 5s are 10, 10 by n plus 2 4s are 8 r by n squared, 8 r by n squared equals limit n tends to infinity can be separated as 10 by n, just you have to write 1 by n outside the summation, sigma or equals 1 to n, 10 is inside the summation, plus here 8 by n squared, it's outside the summation, sigma or equals 1 to n, or is inside the summation. So 10 into 1 by n, 10 by n, 8 into r, 8r by n squared, same only. We know that sigma or equals 1 to n, a, that is equal to an. Here a refers a constant. Here what is the value of a? 10. So limit n tends to infinity, write 1 by n as it is. According to this result, a value is 10, therefore you have to write 10n. What's the value? 10n plus 8 by n squared. You know the result for sigma or equals 1 to n, or you can directly write n into n plus 1 by 2. Okay, 1 n get cancelled, n get cancelled. So limit n tends to infinity, 1 into 10, 10. 2 table 4 times, write 4 into n plus 1 by n plus 1 by n. That is equal to limit n tends to infinity, 10 plus 4 into, can be separated as n by n plus 1 by n, n by n plus 1 by n. N get cancelled equals limit n tends to infinity, 10 plus 4 into 1 plus 1 by n. Now you can replace n by infinity. 10 plus 4 into 1 plus 1 by n as infinity. That is equal to 10 plus 4 into 1 plus 1 by infinity value is 0. That is equal to 10 plus 4 into 1 plus 0, that is equal to 1, equals 10 plus 4, that is equal to 14. Can verify. Verification. The given question is integral 1 to 3 2x plus 3 into dx, that is equal to 2, write as it is, x power 1 integration is x power 1 plus 1 divided by 1 plus 1 plus 3 dx, 3 constant, integral dx is x. Here, which formula we have applied here? I write the formula over here. You know that integral x power n dx, that is equal to x power n plus 1 by n plus 1. Remember. So that is equal to 2 into x squared by 2 plus 3x limit 1 to 3. 2 to get cancelled. Now you can apply the upper limit. Upper limit is 3. 3 squared is 9. 3 3s are 9. Upper limit is over. Minus. Can apply the lower limit. What is the lower limit? 1. 1 squared is 1. 3 ones are 3. 9 plus 9 is 18. 3 plus 1 is 4. 18 minus 4, that is equal to 14. Here also same 14. So problem number 3 is over. So only one problem is left, that is problem number 4. I will be teaching in the next video. Thank you, children. This is Sivakumar, 12th Standard Business Mathematics and Statistics, Chapter number 2, continuation of exercise 2.11. Evaluate the integral as the limit of the sum. It's a last problem in this exercise. Integral 0 to 1 x squared dx. This is of the form integral a to b f of x dx. Here f of x equals x squared. A is the lower limit 0 and b is the upper limit 1. Then you have to find h. H, that is equal to b minus a by n. B value is 1 minus a value is 0 divided by n, that is equal to 1 by n. Then you have to calculate f of a plus r into h, that is equal to f of a value is 0, r into h value is 1 by n. That is equal to f of 0 plus r into 1 by n equals r by n. That is equal to f of r by n equals. We know f of x equals x squared. F of x equal x squared. So x should be replaced by r by n. So this can be written as r by n the whole square equals r square by n square. We know that integral a to b f of x dx equals limit n tends to infinity, h tends to 0, sigma r equals 1 to n, h into f of a plus rh. That is the formula. No integration over here. Therefore, integral. Write the question. Integral 0 to 1 x square dx equals limit. You just write n only. N tends to infinity. No need to write h. Straight away, sigma r equals 1 to n. H can be replaced by, what is the value of h? 1 by n. Since h in terms of n, you no need to write h tends to 0 in the second line. Remember, f of a plus rh, here it is. What is the value? R squared by n squared. R squared divided by n squared. That is equal to limit n tends to infinity, sigma r equals 1 to n. 1 into r square divided by n into n squared is n cube. Limit n tends to infinity. 1 by n cube is outside the summation and r squared is inside the summation equals limit n tends to infinity 1 by n squared. Already I have given the result for sigma r squared. Sigma r squared can be replaced by n into n plus 1 into 2n plus 1 divided by 6. One n get cancelled. Here n cube, r squared by n cube. Sorry, here n cube. 1 n get cancelled, so 3 becomes 2. So limit n tends to infinity, write the constant 1 by 6 first. After that, next step, n plus 1 and 2n plus 1 divided by, we have n square, no, here 1n, here 1n, n into n square. Limit n tends to infinity, constant is 1 by 6. Next step, n by n plus 1 by n. 1 by 6 can be separated as n by n plus 1 by n. Next one can be separated as 2n by n plus 1 by n. 2n by n plus 1 by n. N cancelled, 1 will be there, 1 will be here. Sorry, 2 into 1. That is equal to, no need to write that one. N get cancelled, you can write 2 only. So limit n tends to infinity, 1 by 6, 1 plus 1 by n. N get cancelled, 2 will be there, plus 1 by n. Okay. Now replace n by infinity. Wherever n comes, that should be replaced by infinity. So 1 by 6, 1 plus 1 by infinity, 2 plus 1 by infinity equals 1 by 6, 1 plus anything by infinity is 0, 2 plus, so 1 by infinity is 0, that is equal to 1 by 6, 1 plus 0 is 1, 2 plus 0 is 2 equals 1 into 1 into 2, that is 2 divided by 6, 2 table 1 time, 3 time, that is equal to 1 by 3. So verification part. The given question is integral 0 to 1 x square dx. Integral 0 to 1 x square dx equals, we know that integral x power n dx equals x power n plus 1 by n plus 1. N here 2, so n value is 2, replace here, x power 2 plus 1 divided by 2 plus 1. Limit 0 to 1, that is x power 3 divided by 3, limit 0 to 1. First write 1 by 3, so you have only x cube. Apply the upper limit, replace x by 1, 1 cube is 1, minus 0 cube is 0. 1 minus 0 equals 1, 1 into 1, 1, 1 by 3, same 1 by 3 here. So last problem is over, exercise over, even chapter over. So I'll be teaching the next chapter in the next video. Thank you, children.